voltages from the marker potentiometers feed two independent computer chains. One operates the markers, and the other feeds the pilot's steering circuit. By feeding extra information into the marker circuit, it is possible to place the selected reference point A under the markers, while the pilot's indicator guides the aircraft to an entirely different point B. This second point need not be visible as a radar response. It is only necessary to know the distances north-south and east-west of the reference point A from the homing point B. These distances, the offset coordinates, are inserted manually into the marker circuit. The accuracy of the latitude and longitude counters is maintained by feeding in the exact position of the aircraft from time to time to remove accumulated errors. A certain amount of time must be spent in pinpointing the aircraft's position. Information on the aircraft's movement during this time interval is stored by the marker potentiometers. At the instant of switching to fix, when the aircraft is at point A, the numerators are disconnected from the ground speed drives. The ground speed drives are connected instead to the marker potentiometers, so the marker intersection will remain on the point A. The subsequent movement of the marker potentiometers represents at any time the distances north-south and east-west traveled by the aircraft from point A. On switching back to normal, the marker potentiometers are driven back by the setting motors, which also drive the numerators by the same amount. Thus, the movement of the aircraft while the switch has been on fix is fed into the numerators. To check the aircraft's position on a G-fix, the function switch is turned to fix as the aircraft passes through a known G position A. The numerators are checked against the known latitude and longitude of the point A and are corrected manually if necessary. Switching back to normal resets the numerators to read the corrected position of the aircraft at that instant. Any clearly defined radar response P, whose latitude and longitude are accurately known, may be used to obtain a fix. When the function switch is on fix, it is arranged that the numerators are connected to the setting motors controlled by the joystick. Having selected fix at point A, the joystick is used to move the selected point P under the marker intersection. As the numerators are connected to the setting motors by M transmissions, they will follow the movement of the markers and will move by the coordinate distances of P from A. Since the numerators were disconnected from the ground speed drives at point A, they should now read the latitude and longitude of P. If not, it means that they were incorrect when fix was selected at A. The necessary corrections are applied by resetting the numerators manually to the known latitude and longitude of the point P. On switching back to normal, the setting motors drive the marker potentiometers to 0. At the same time, the numerators are reset by an amount equal to the vector sum of the coordinate distances of A from P and the distance traveled since selecting fix. When the marker potentiometers reach 0, the warning light ceases to flash, the numerators are reconnected to the ground speed drives, and normal DR computing is restored. The numerators now read the corrected position of the aircraft.